Hi, my name's Breslin and I'm an AI scientist. I've spent my career working in voice and language technology, and I've worked some of that in academia, some of that working on products. I've worked at Amazon Alexa, and more recently I work as a consultant where I advise a lot of companies who are building AI. Over the past decade, excitement about AI has been building. AI has a long history, but the launch of recent models from big tech companies has really brought AI to the forefront of people's minds. That's especially true when we think of some of the image and text models, like ChatGPT, that are making the news and are being integrated into tools that we use daily. Many of the AI systems that we use are cloud-based. We might interact with them via our phone or our home computer, but we're really just entering our data there, and the real processing happens in the cloud. For example, while I can speak to a virtual assistant on my phone, that audio of my voice is being streamed up to the cloud, processed on powerful machines there, and then just the result is sent back to my phone. This way of working means that everyone can have access to powerful technology that they couldn't run locally. But this cloud setup isn't the only way to run AI models. And those popular consumer text and image models aren't the only applications of AI that we might be interested in. There are many devices that we could instead use to run AI models locally at the edge. It could be, for example, that we want to run AI models directly on our phone, or perhaps on something like a Raspberry Pi, or maybe even a custom IoT device that we've built that has specific sensors or a specific form factor. There are many reasons why AI at the edge on these kinds of device might be preferable to AI in the cloud. Cloud services rely on us having a reliable network connection for one, but we might find ourselves in an area with a poor connection. Or even if the network is mostly reliable, we might be working with critical infrastructure that needs very high availability and that can be run at the edge to mitigate any network issues. Something like a wearable healthcare monitoring device, for example, may need to be working all the time, and so we want processing to be happening on the device itself. Or smart city infrastructure, say for managing traffic flow, needs to have high availability so it can be run on the edge for reliability. Another advantage of running on the edge is to do with the speed of processing and reducing latency. When you're running in the cloud, you've got a delay added into responses, which is due for the time it takes for your data to be sent up to the cloud and the response sent back again. That delay can be something in the range of maybe 50 to 200 milliseconds on average, but could be even higher if, for example, there's high network load. That extra response time can be bad news for a real-time system. Use cases like industrial automation or self-driving cars can be very sensitive to even small delays. Running AI on the edge avoids the round-trip time and allows your system to respond faster, in real time. Another motivation for AI on the edge is for data privacy and security. It's not a complete solution, but processing data locally removes both the transmission of data across the network and also removes storage of that data on a cloud machine. That can make it easier to keep your data secure. A fourth reason for using edge AI is because these edge devices are often low power. By designing our models to work on edge devices, we can reduce the energy consumption, and that allows us both to save on costs and also to reduce the carbon footprint. And this is really important in the current moment, when we're looking to reduce the environmental impact of AI as a whole. So, whether for high availability, for speed, privacy, or energy saving, there are some really strong motivators for using AI at the edge, and hence for teaching some of the techniques and technologies that allow us to run state-of-the-art AI models directly on low-resource edge devices.